FFVMD. Welcome back. Today's topic is mechanical properties of solid. Body with definite shape and size is called solid. Strength of material. It is defined as an ability to resist its failure and behavior under the action of external forces. Restoring forces. Whenever external forces are applied on a body, it undergoes some deformation, and the molecules of the body after resistance to the deformation. This resistive force is called restoring force. Let we see the definition. Whenever external forces are applied on a body, it undergoes some deformation, and the molecules of the body offer resistance to the deformation. This resistive force is called restoring force. Restoring force vanishes after removal of external forces. Elasticity, the property of a body by virtue of which it tends to regain its original shape and size when the applied force is removed, is unknown as elasticity, and the deformation caused is known as elastic deformation, and the body is called perfectly elastic body. Plasticity, if the body have no gross tendency to regain their previous shape and size after the removal of applied force, and they get permanently deformed, is called plastic, and this property is called plasticity. A stress, when an external force is applied to a body, then at each cross section of the body an internal restoring force is developed, which tends to restore the body to its original state. The internal restoring force for a unit area of cross section of the deformed body is called a stress. It is usually denoted by sigma. Thus, stress equals to restoring force by area. SI unit of stress is Newton per meter square or Pascal. This is called Pascal. It is also the unit of pressure. And dimensional formula is mlt minus 2 by L2, ml minus 1, t minus 2. Longitudinal stress. If the restoring force is along the length and normal to the area, then normal restoring force per unit area is called longitudinal stress. It is denoted by sigma n. Hence sigma n equals to Fn by A, where A is the cross section of cross-sectional area. Fn is equal to normal restoring force and F equals to normal applied force. If the applied force is to stress the length, then longitudinal stress is called a stress, and if the applied force is to stress the length, then longitudinal stress is called tensile stress, and if the applied force is to compress the length, then stress is called compressive stress. Both the condition is shown in figure. Now tangential or shearing stress, sigma t. If the applied force is along the surface of the body, then tangential restoring force per unit area is called tangential stress. As shown in the figure, a force is applied to parallel to the surface. Then a restoring force acts in opposite to the applied force. In this case, the stress developed is called tangential stress, and it is given by sigma t equals to tangential force by area. Sigma t equals to ft by a, where ft is the tangential force and a is the surface area. Volume stress or hydraulic stress. If a solid under high pressure is compressed uniformly on all sides, the internal restoring force for unit area in this case is known as hydraulic stress or volume stress. Sigma V equals to F by A. The situation is shown in the figure. A spherical body is put inside a water. Then it will be compressed by the pressure of water from all directions, and in this case the stress developed in the body is a hydraulic stress. Let us look. The stress can be divided into two parts: longitudinal, tangential, and hydraulic. Now longitudinal is of two parts: tensile and compressive. Now our another topic is strain. It is defined as the ratio of change in shape and size of body to its original shape and size. A strain equals to change in size by original size, or E equals to delta x by x. A strain has no unit and no dimension. Longitudinal strain. The change in length divided by the original length is called longitudinal strain, or EL equals to delta L by L, where delta L is the change in length and L is the original length. Similarly, volume strain. It is the ratio of change in volume to the original volume. EV equals to delta V by V. This strain is caused by hydraulic stress. Shearing strain. It is defined as the angle through which the one surface of a body parallel to another surface is displaced. Here the situation is shown in the figure. The upper surface is inclined by an angle theta and it is displaced of a distance delta x. Then we can write shearing stress is given by E theta equals to theta equals equivalent to tan theta equal to delta x by L. So E theta equals to delta x by L. The shearing strain may be defined as the displacement of one face relative to another face divided by distance between them. Elastic limit or yield strength sigma y. The value of a strength beyond which the body loses its property of elasticity and it does not regain its original shape and size when the deforming force is removed. It is the maximum stress that a body can bear and it returns to its original state. It is the characteristics of material of the body. Hooke's law. Within elastic limit, a stress is directly proportional to a strain. That is, a stress proportional to a strain, or a stress equals to K into a strain, where K is a proportionality constant. Where K is the proportionality constant and is known as modulus of elasticity. Now a stress-strain curve. A metallic wire is hanged with a pan with some weight. There will be developed an elongation in the wire. Now see what happens to this in this condition. In the region between O to A in the graph, the curve is linear. In this region, Hooke's law is obeyed, and from A to B, stress and strains are not proportional, but the body still returns to its original dimension when the load is removed. The point B in the curve is known as yield point or elastic limit, and the corresponding stress is called yield strain sigma y of the material. The region B to D is called a plastic limit. B to D is called a plastic limit. In this region, at any point C, say, the body does not regain its original shape as load is removed. The deformation is said to have a permanent set and is called plastic deformation. The point D on the graph is the ultimate tensile strain, sigma u, of the material. Sigma u of the material. The point D on the graph is the ultimate tensile strain, sigma u of the material. Beyond this point, additional strain is produced even by a reduced applied force, and fracture occurs at point E. If the ultimate strain and fracture point D and E are close, the material is said to be brittle. If they are far apart, the material is said to be ductile. From figure OAB, this is a graph between a stress and a strain. So the graph from OAB shows the elastic behavior. BCD shows plastic behavior. BCD shows plastic behavior. OA, from O to A, Hooke's law can be applied, means OA follows Hooke's law, and AB regain its original shape and size, but Hooke's law is not followed. From B to D, plastic limit, permanent deformation when load is removed, and D to E, additional strain produced even load is reduced, and E is the fracture point. If D is small, material is brittle, and big, material is ductile. Our next topic is elastomers. Some substances can be pulled to several times of their original length and still return to their original length after the removal of deforming force. Such substances are called elastomers. Example: rubber, aorta, large vessel carrying blood from the heart. Although elastic region is very large, the material does not obey Hooke's law over most of the region. FFBMD. Modulus of elasticity. Our next topic is modulus of elasticity. It is defined as the ratio of stress to strain within elastic limit. That is, modulus of elasticity equals to stress by strain. Types of modulus of elasticity. First, Young's modulus of elasticity, and represented by Y. It is defined as the ratio of normal stress to the longitudinal strain within elastic limit. It is denoted by Y. Hence, Young's modulus equals to longitudinal stress by longitudinal strain, or Y equals to sigma n by EL equals to Fn by A divided by delta L by L, or equals to FL by A into delta L. Unit of Y, unit of stress, Pascal, and dimensional formula of Y means Young's modulus of elasticity equals to dimensional formula of stress, ML minus 1 T minus 2. Second, shear modulus or modulus of rigidity, the ratio of shearing stress to the corresponding shearing strain, is called the shear modulus of the material and is represented by G. So, shear modulus or modulus of rigidity equals to shearing stress by shearing strain. G equals to F by A by delta X by L equals to FL into F into L by A into delta X, or G equals to F by A into theta, or F by A theta, where theta equals to delta X by L for a small deformation. For most materials, G equals to Y by 3. This is the relation between shear stress and Young modulus of elasticity. Shear modulus and Young's modulus of elasticity. Buck modulus, B. The ratio of hydraulic stress to the corresponding hydraulic strain is called Buck modulus. Buck modulus hydraulic stress by hydraulic strain, B equals to F by A divided by minus delta V by V equals to delta P into minus V by delta V equals to minus delta P into V by delta V. Negative sign because volume decreases when pressure is increased, and modulus of magnitude of modulus Buck modulus of elasticity is given by delta P into V by delta V. Our next topic is compressibility. The reciprocal of the work modulus is called compressibility and is denoted by K. Hence K equals to 1 by B equals to minus delta V by delta P into V. Application of elastic behavior of materials. Question: what should be the radius of cross section of a cylindrical steel wire if a load of 1000 kg is hanged from the wire? The yield strength SY strength of steel is about 300 into 10 to the power 6 Newton per meter. That is, for safe hanging, a stress must be less than equal to yield strength, or mg by pi r square must be less than equal to Sy, or mg by pi into Sy is less than equal to r square, or r must be greater than equal to under root m into g by pi into Sy. Answer. So this is all about the properties of material, elastic property of material. Next, we will come back with new topics, and so goodbye. Thank you for viewing my video. That's all.